All right, this video is about the importance of T-charts, and I just feel like some of you might need to watch this video, so I'm going to make this little video and have it accessible. If I notice that you're not doing the T-charts the way that I'm teaching you, I'm going to have you watch this video during class. All right, so when we have a problem like, let's say, x plus 3 equals 6, just understand that it's not that I don't think that you can do blank plus 3 equals 6. I know that you know that x is going to be 3, okay? And I've told you guys that. But what I need you to do is understand the importance of the T-chart, because later on we're going to have some crazy looking examples that it's going to be harder for you to do in your head mental math. So we're going to start with doing our T-chart. Remember that we put a line that goes through our equal sign, and then we give ourselves some space to write, and we go down, like, let's say this is line paper, you go down one line, and we underline our equation. And so now, we always need to remember that the primary goal is to get this variable all by itself. So the key now is to look at this, which is the part that's attached to the variable, and we have to think about how are we going to get rid of that 3, that plus 3. And what we figured out when we were working on the scales is that if we take away 3 from this side and we take away 3 from this other side, that our scales stay balanced. So I'm going to take away this plus 3 with the minus 3, and this is gone. And I like to go ahead and draw that line through it to represent that the positive 3 and the minus 3, they cancel each other out. 3 minus 3 is 0. I don't need to write 0, okay? I know that that's 0. I don't need to write it. But what I do need to do is bring down my variable, which is the x, because that's what's left over here. I want to bring down my equal sign, and then I can do my 6 minus 3, which is 3. Now the check work portion, and this is something that I do want you guys to always do. I really want you to check your work every time, because then you're not going to get it wrong. We can check our work by taking the original and substituting in what we came up with, the variable for 3, for x, I'm sorry. So I'm going to do 3 plus, well here, let's write it like this. The original OSS, the original is x plus 3 equals 6. I said down here that x equals 3, so I'm going to plug in 3 plus 3. And we're going to see if it's equal to 6. So 3 plus 3 is 6. 6 is equal to 6, and there's our check mark. Okay, so our answer is not, the 6 equals 6. It's the x equals 3. Okay, that is our answer. All right, let's do another example. And this time we're not going to use such easy numbers. So our next example we'll say is 3.2 equals k plus 4.5. Okay? And so, oh, no, that's not going to work. Sorry. I'm trying to do this on the fly. 2.5. Okay? So here's an example where using our T-chart is going to be helpful, because I don't think that when you guys look at this and you say, okay, plus 2.5 equals 3.2, I don't think it's automatic like it is with 3 plus 3 equals 6. So, and sometimes we trick ourselves into thinking that we have the right answer, and we don't. So it's just another reason to go ahead and set up our T-chart. Remember that we put it through the equal sign straight down, give ourselves some space to work, like one line, and then we draw a line underneath our equation. So now remember again that we want to get the variable by itself. So I need to look at this plus 2.5, and I have to think to myself, what can I do to get rid of plus 2.5? And the answer to that is subtract. It's called the inverse operation. It's the opposite of add. It's subtract. So remember, what I do to one side, I do to the other. So I'm going to take the 5.2 and I'm going to subtract that 2.5. So now over on the right hand side here, and this is why we put the line through the equal sign, because our variable is not always on the left side. In this case, our variable is on the right side. The point is that we're just trying to get this to be a 0 right here. So that's gone, and we bring down our k, and we bring down our equal sign. And now we can do 3.2 minus 2.5, and we get 0.7 is equal to k. Remember that we also want to check our work, because that's something that's very important. We circle our answer here, and then we're going to check our work. So we're going to do, all right, k plus 2.5 is what we're looking at. So I'm saying 0.7 plus 2.5. That's going to equal, sorry, I didn't line those up. Let me try this again. Okay, plus 2.5. We've got 12, carry the 1, that's 3, and then our decimal point, 3.2, check mark. And that's how we check our answer. We just plug it into the original equation and then solve, and hopefully we come up with the original answer. But remember that the actual answer, sorry, the actual answer is 0.7 is equal to k, or k equals 0.7. All right, I know that some of you guys were struggling with fractions, so let's go over an example with fractions. Let's see, I've got 1/5 plus j equals 2/3. Okay, so that's our original equation. I'm going to go ahead and set up my t-chart, which means a line through my equal sign, and then give a space, and then underline the equation. Now I'm going to look at my variable is my j, and I want to get that by itself, and what I'm looking to get rid of is this 1.5. Now how can I get rid of 1.5, or sorry, 1.5, 1/5? How do I get rid of 1/5? I do the opposite, and I subtract. What I do to one side of the equal sign, I do to the other. So I'm now left with j is all by itself. I bring down my equal sign, because this is gone, right? I bring down my equal sign, and now I have to figure out what's 2/3 minus 1/5. The way it is right now, guys, we cannot do it. I have to find the common denominator. So we look for the least common denominator. We look at our 3 and our 5, and we think of our multiples of 5. We've got 5, 10, 15, and we have to think of the number, the first one that comes up that can work with 3. That's the one we're going to use. And sure enough, in my example right now, I'm going to be using 15. So I have to subtract, excuse me, I'm going to be subtracting 15ths, not thirds and fifths, because those are two different pieces of pie, 15ths, where they're all equal slices. So I need to change my 2/3 to 15ths. Well, to go from 3 to 15, I multiply times 5. So what I do the bottom, I do the top, and so that's going to be 10/15 minus, and then we're going to do the same thing. How do I go from 5 to 15? We multiply times 3. What I do the bottom, I do the top, and so we've got 3/15. So 10/15 minus 3/15. I keep the denominator the same, and I do 10 minus 3. I subtract my numerators, and I get 7/15. So j is equal to 7/15. I'm going to erase all this because I still want to check my work. I don't want you to erase it, but I just need more space to work here. So now I need to check my work, and checking my work, I'm going to do, back to the original equation, 1/5 plus j, 1/5 plus 7/15. To be able to do that, I need to have common denominators. So again, 15 is going to be my common denominator. Of course, this isn't as fast and easy as the other ones were, but it's going to be fine. To go from 5 to get to 15, I would multiply times 3. When I do the bottom, I do the top. And I've got 3/15 plus 7/15, which equals 10/15. And if I simplify that, I get my 2/3 check mark. I know that wasn't a very fast check like we can do on our other ones, but when we're dealing with fractions, it's probably even a better idea for you to go through this extra bit of effort to figure out whether or not it worked. So our final answer is that j equals 7/15. All right, guys, so that's about a 10-minute review on just using the T-chart, simple addition stuff, but with a little more to it. Please realize that there is a huge importance for doing our T-charts. You're going to end up seeing problems like this as you get further along in algebra, in 8th grade math, probably 7th grade math. You'll have a problem like this. And although I know you'd love to be able to say, oh, I can do that really fast, that's not the case. Okay? It's a process that you have to work through in your mind. And without using the T-chart and going step by step, which is more that you're going to learn later when you work on two-step equations, you need to know this. You need to know the basics here. So using the T-chart is going to be really important. And trust me, you're going to use it. All right, guys, I'll talk to you later. Thanks so much for watching. Bye.